Welcome back to this video series of C++ programming. This is the lecture 8 of this video series, and today we are going to talk about static members in C++. But before that, we'll first understand the static members in C programming. So it will create us background to understand the static members in C++. We'll see the use of static members through an example. First thing, static is a standard C programming keyword. It is also a standard C++ keyword. In C programming, stat is also one of the storage class. So there are four kinds of storage classes in C programming: static, auto, extern, and register. So in C programming, static is one of the standard storage class. When you talk about the storage class is associated with the variables. And when you talk about them, the two things comes to your mind. First one is a life of that variable, and another thing is the scope of that variable. These are the two important things related with the storage classes. The storage class for the static variable depends where you create this variable. So there are two ways you can create a static variable in the C programming. First, add the global scope in the file, and second, add the local scope in the function. So what is the global scope of file? So when you create that variable inside your file and at the global scope or at the start of that file, that is outside any function, then that scope of that variable is a static global. And when you create any variable inside any function and with the static keyword, then that scope of that variable is local to that function. First understand how we can create a static variable at the file global scope. So you have to specify the static keyword, and then after the data type of that variable, say integer, and then the name of that variable. So now the data variable is one variable which comes under the file global scope. So what is the file global scope? When you create a variable, then this variable is accessible inside this file only. So that means you cannot access this variable outside the file. The only way to access this variable from the outside modules is by use of a function. So the outside modules have to call function present in this file, and through that function they can access that variable data1. But it is not possible to access this data variable outside this module or outside this file from the other files or other modules, and that is the use of the static keyword here. The second is the life of this variable when you create at the file global scope. So life is how long that variable exists in your program. So when you create this data1 variable at the file global scope, then the life of that variable remains throughout the program. That means as long as your program exists, this variable exists. And the reason is this variable is stored in a data memory. So it is stored in a data memory. And as you know, the data memory content of data memory remains as long as your program is present. So that's why the scope of this or the life of this variable is throughout your program. So this is about the static variable present or declared in a file global scope. When you create a static variable inside the function in a similar manner, for example, I have created this variable inside the main function, then the scope of this variable remains inside this function only. That means this variable is not accessible or cannot be accessed outside this main function. Then the life of this variable is again remains throughout a program. That means as long as your program is present, this data2 variables remain in data memory. And this important properties makes these variables retain its values across the multiple calls of this main function. So for example, in this program you are incrementing the data2. Every time when this function is called, this value is retained every time. The previous value is written every time when you call this function, which is not the case when you create any local variable. So if you create any variable and without the static keyword, Then this variable is typically stored in a CPU registers or stack, and whenever you exit this function, this variable is destroyed from that stack or from the CPU registers. So next time when you come back to this function, this value of this variable would be some garbage value. But in case of a static variable, by default the value becomes a 0. So when you create the variable for the first time, the value it will hold will be a 0. And whenever you increment this value will be returned, the previous value returned whenever you call this function. So suppose you have incremented this value data2, now it has become a 1. Next time you call this function, the data2 will hold the 1 rather than holding any garbage value or a 0 value. So that is the important property of this variable when you create inside the function. So we talked about the static variables in C programming, and we saw how we can create the static variable, one inside the file global scope and another inside the function scope. But in C++ programming, the static variables are used differently. So we'll see how the static variables are used in C++ programming. In C++, both function and data members of a class can be made static. When you precede a member variable's declaration with static, you are telling the compiler that only one copy of that variable will exist and that all objects of that class will share that variable. This is a very important point. And it says when you create a multiple objects of a particular class inside the static member variable is declared, then no matter how many objects you create, the only one copy of that static variable is created, and this copy of this static member is shared across the multiple objects. We'll see this with an example. All static members are initialized with 0 before the first object is created. We'll talk about this point with an example. Let's understand the syntax of a static members. So on the left side you can see the declaration of this class, and inside this class we have created one static member variable. So this is starting with the static keyword followed with the data type and then the name of that variable. So this becomes a declaration for this static member variable. And on the right hand side you can see this is a definition of this static member variable. So it is required that you define the static member in this particular manner in C++ programming. So this is the name of the class followed with these two colons, which is the scope resolution operator, and then the name of this static member variable which we have declared here. So we are creating a membership label to this variable, and we are saying this member is associated with this class test. So let's understand this static members through an example. First I will declare this statement which includes the iostream header file, and then this using namespace std statement to resolve the scene and cout objects. Now we'll create one class here, and inside this class we'll create one static member variable, and I will create one public member function, and this will display the content of this data variable on the console window. Now this is not a static member function, this is just a normal member function, but this data one is a static member variable. Here inside the main function I will create an object of this class C1. So now with this object we can access this static member variable. But before that we must define this static member here outside this. I will define this as outside this main function. So how we can define is the name of the class and then the scope resolution operator and the name of this variable. So this is the definition of this variable. When you define the variable, you can also assign the value to this variable. So suppose I'm assigning the value 20 to this variable. Even if you don't define the value, it will hold the 0 value. So even before creating the first object, we can define the value in this static member variable. Now with this object, we can access this uh, variable, but since this is a private member, we cannot access the static variable directly. So if I specify the object name and then the dot operator, we can see only this display data function is accessible to this object. So through this display data function, we can access that static variable. Alright. So we talked about the most important feature of static members is that no matter how many objects you create, only one copy of that static member is created. So we'll see this concept with the X by creating the multiple objects. So here I will create another object of the same class C1. We'll call this as object 2. First we'll write another function that will save the value of this variable data1, and I'll pass this value in this function. So here first I will assign the value of that static variable through this objects. So for this object 1, I'm setting the value of data 1 as a 20, and for the object 2, I specify the value as a 30, and we will display this value onto the console window for this object 1 and object 2. And now can you guess what would be the value of this uh, what would be the value of this data when you call these two functions? Because we're initializing one value of the data one which is associated with the object one as 20 and another to a 30. Well, let's compile a program and see what does it outputs. So it is outputting value as the 30, both value as 30. Now why 30? Because as we talked before, this data static members are shared across the multiple objects. So even when you create the multiple copies of this variable, the only one copy of this variable is created. So unlike the normal member variables, suppose we create a variable this without the static keyword, then when you create the multiple two objects, the two different copies of this data one variable is created, which is not the case with the static variable. That's the reason here when you call this function set data, first the data one is stored with the value 20 in this function. Next time when you call this function set data with the value 30, then the previous value of this 20 is replaced with the new value 30, since it is only one copy or only one memory location. That's the reason it is displaying the value as a 30, which is the latest value stored in that variable. So this is how we so this is the significance of the static member variable. Now even as we know, this static variable is not associated with any particular object, so even we don't have to use this object name to access those static variables. So suppose now I create this another variable which is of a static which is a static member. I will call this as data2, and I'm creating this variable outside the I'm making this variable as a public. So now this variable can be accessed outside the class in this main function. So inside this main function, I can call this data2 variable in two different ways. One, obviously by using these objects, and another by specifying the name of this class, then the scope resolution operator, and the name of that variable, as you can see here. So this is one way, and another way is like creating the uh, another way is through this object. So since this is not associated with any object, we can directly use the syntax. Why do we need static members in the programming? The first thing, creating a static members almost eliminate the use of the global variables. So as we know, there is a problem with the global variables, and if they are as they are shared by the multiple modules, and there is a more chance of getting it corrupted. But when you create the static variable, we are returning all the important features of the C++ programming. The first one, when you create this as a private member, then we are making sure it is not accessible outside your class, that is, it can be accessed through only public members of that class or protected members of that class. And when you create it in the public, we are making sure it is only accessible through this through the object of that particular class outside your this class. So this is not accessible by another module which has and in which the object of this class is not created. This is how we eliminate getting this variable corrupted by access through multiple modules. So we saw the concept of the static members in the C++ programming. Now we'll understand the static member functions in the C++ programming. So this you can see on the left side is a syntax of a static member functions. So when you create a static member function, you have to specify this static keyword and then the name of that function. You can create the static member in the class itself or outside the class itself. But let's understand this more about the static members through example. So now this display data function, I will change it to a static. And when you create a static member function, the most important feature of static member function is the static member can access only the static variables. So they can access only the static data members. They cannot access the non-static data member. The static member function can be uh, defined outside the class. And how? When you define this function outside the class, you don't have to specify the static keyword again, but you have to specify this class name and the scope resolution operator, that is a membership label. And here we have to specify, this is a prototype, so you have to specify the static keyword and the name of that function. So this is another way we can create the static member functions in the C++ programming. So how we can call the static members? The first way is by using that object. So then object and the name of that member function. The another way, as we similar to this static member variables, we don't have to use the objects to call this member functions. So if you specify the class name and then the name of that member function, and in between the scope resolution operator. So this is another way we can call this static member functions in the C++ programming. Since the static members are, so since this member function is only using the static data members, it is possible to access this static member functions without the use of an object. Alright, so this is how the static member functions works in the C++ programming. Now let's talk about some of the important points about the static members in C++. First, by using the static member variables, you should be able to virtually eliminate any need for the global variables. So we talked about this point when you saw an example. Second, static members can be initialized or used even before any object of a class is created. As we talked before, even creating this object, we can initialize the static members to any value, but you need to define this static variables. Third point, static member functions can access only static member variables. Global functions and data may be accessed by static member functions. So as we saw just now, static member functions, so the static member function, it can access only the static data members, even though it can access the other global variables or the global members. So if I create any variable here, say this data 3, then I can access this data 3 variable inside the static member function. And the compiler should not give any error. So if I compile the program, then it compiles error free. The fourth important point, a static member does not have this pointer. So we'll talk about this pointer in the upcoming videos, but for now understand the static members doesn't use this pointer. There cannot be a static and non-static version of the same function. So you cannot create a same function with a static and non-static keyword and the same name. And the final point, static member function may not be virtual. They cannot be declared as a constant or volatile. So this is also a very important point. We'll talk about the virtual functions in the upcoming videos. Alright, so this is all about the static members in C++ programming. I hope now you have understood the concepts related to static members. So thanks for watching this video and stay tuned for the upcoming videos.